The Royal Australian Navy is structured, equipped, trained and supported to deliver combat power at sea, to fight and win in the maritime environment in support of Australia's national interest. To achieve this, clearly a great deal is involved. Force structure, battle readiness, logistic support and so on all must be managed in accordance with prevailing doctrine, whilst for personnel, leadership, discipline, morale and training are also essential. The most tangible elements of naval capability, however, are and always have been the actual combat instruments themselves. That is, the ships, submarines, aircraft and support vessels that combine to make up an effective maritime force. The aim of this program is to provide an insight as to each class of vessel currently operated by the RAN, their design, purpose, fit-out, capability and so on. More than that though, we'll attempt to explain the actual role of these vessels in a broader historical and political context, how our Navy has evolved into what it is today, and how world affairs and technology are shaping the Navy of tomorrow. To begin, let's take a look at the existing structure of the fleet. All RAN fleet units are assigned, according to their nature, to one of 7 core agencies known as force element groups. They are submarine, major surface combatant, amphibious and afloat support, patrol, mine warfare, aviation and hydrographic survey. All these forces are controlled by the Maritime Commander Australia and, depending on operational requirements, may be integrated in various ways. Generally, however, each force element has a very specific role to play in our maritime security. So, in order to understand them, it's important to examine them individually. We'll start with submarines.
The modern submarine is without doubt the most lethal and menacing weapons platform in human history. Fast, covert, heavily armed, extremely difficult to detect and kill. When it comes to the business end of naval warfare, boats such as this 6,000-ton Los Angeles-class hunter-killer sit very, very close to the top of the food chain. Their evolution can be traced back 60 years to World War II, the Atlantic Ocean, and Germany's dreaded U-boats. Operating in groups of up to 30, these submarines were so terrifying and effective in their own right that they very nearly cost the Allies the war. During just one 6-month period in 1942, 568 ships totaling over 3 million tons were sent to the bottom. Even by 1944, and with their famous Enigma code broken, the Nazis still had over 235 U-boats wreaking havoc throughout the Atlantic. The sobering fact is that Admiral Dönitz, architect of the German U-boat program, achieved all of this with a submarine design that by today's standards would be considered about as offensive as a paddle steamer. A modern submarine is almost invulnerable, even to the most sophisticated underwater weapons and sensors. Though submerged, it can travel faster than almost anything on the surface and strike hard and decisively at a time and a place of its own choosing. To understand these machines and how they work, however, it is important from the outset to realize that all submarines currently in service with world navies can be divided into 2 very separate, very distinct categories. In the first are the massive nuclear-powered vessels known by the designation SSBN, Strategic Ballistic Missile Nuclear-Powered Submarine. These leviathans, operated by just 5 of the world's nations, are designed solely for use in all-out strategic nuclear war and are armed with the ultimate deterrent, long-range thermonuclear ballistic missiles. The gigantic 27,000-ton, 170-meter-long Typhoon class, up to 6 of which are still operated by the former Soviet Union, is a good example of the frightening destructive potential of these vessels. Its payload of 20 SSN-20 missiles represents more firepower than that expended by all nations in the 2 world wars combined. Such is the range of its weapons, the Typhoon can hit any target on the globe without ever leaving Russian waters. In the second category of submarines, much smaller, faster, more prevalent boats, optimized for conventional warfare. Known as patrol, attack and hunter-killer submarines, they are armed with heavyweight torpedoes and in some cases subsurface-to-surface anti-ship missiles. Propulsion systems are either nuclear or diesel-electric, with each method having its own advantages. For example, this French Rubis-class SSN is powered by a pressurized water nuclear reactor, which gives it relatively unlimited endurance. Diesel-electric designs, on the other hand, such as the Japanese Yoshio class, whilst far more limited in range, have the significant advantage of being extremely quiet, and when operating in the silent running state, are virtually undetectable. Designed primarily to hunt and destroy surface fleets, modern attack and patrol submarines are also used for intelligence gathering, surveillance and reconnaissance, anti-submarine warfare, mine warfare, and clandestine insertion of special operations forces. Australia's version of this submarine is the SSK Collins class Type 471. Along with the RAAF's long-range F-111 fighter squadrons, these boats will form the backbone of the nation's offensive capability for some decades. Based on a Swedish design, Collins is the first class of submarine ever to be built in Australia, all of the boats being constructed and fitted out by the Australian Submarine Corporation in Port Adelaide. By conventional standards, these boats are huge. In fact, at 78 metres and displacing almost 3,500 tonnes, Collins is the largest conventionally powered submarine in the world. Her range is in excess of 10,000 nautical miles, with an underwater speed in excess of 20 knots. Ship's company is 42, 6 officers, 8 senior sailors and 28 junior sailors. As of March 2003, 6 of these vessels are in commission. All are based at HMAS Stirling, Fleet Base West, Western Australia. The operational philosophy behind Collins is quite different to the previous generation of conventional submarines. Once deployed, she will dive and remain so for the duration of her mission. Once dived, the boat is actually powered by huge banks of lead-acid batteries, the electric motor delivering almost 5.5 megawatts of shaft power, roughly equivalent to the output of around 40 petrol-driven V8 engines. Periodically, typically once every 2 days, she will come up to periscope depth and snort. This allows air to be drawn in through what is known as the induction mast. The boat's 3 diesel generators are then run to recharge the batteries and replenish the atmosphere. Any submarine can only be as effective as the striking power of its weapons, and in this area Collins truly has excellent capability. She carries both the Mark 48 Mod 4 anti-ship, anti-submarine heavyweight torpedo and the encapsulated sub-harpoon anti-ship cruise missile. The Mark 48 torpedo is designed to combat fast, deep-diving nuclear submarines and high-performance surface ships. It has the ability to seek out and destroy its target from over-the-horizon ranges. Driven by an external combustion 6-cylinder piston engine, it can achieve speeds well in excess of the swiftest surface combatants and can dive as deep as the largest and most modern nuclear submarines. Once fired through one of the 6 torpedo tubes, the Mark 48 uses onboard sonar to home in on its target. It remains connected to the sub via a thin wire communications link, allowing the torpedo head to transmit its search data back to the launch platform for more accurate processing. Upon arrival at the target, the torpedo will rise to an optimum depth and position before detonating its heavyweight, high-explosive warhead. On July 14, 1999, the first live firing of a Mark 48 by a Collins class was performed by HMAS Farncombe. From an over-the-horizon distance, the torpedo successfully homed in and engaged its target, the recently decommissioned destroyer escort HMAS Torrens. Footage of the war shot shows the 2,700-ton hull being lifted out of the water before snapping in two, a good indication of the sheer power of this type of underwater weapon. The encapsulated sub-Harpoon anti-ship missile is just as lethal. With a range of up to 70 nautical miles and charge weight of 200+ kilos, Harpoon is also fired through the torpedo tubes, where it sits inside a special casing until it reaches the ocean's surface. At that point, the casing is discarded, and the missile activates its own rockets and fins. Active radar located within the nose cone allows Harpoon to lock onto its target as it dives into its terminal cruise run at just below supersonic speed. The speed, range, accuracy and sea-skimming nature of these missiles make them a truly nightmarish proposition for any surface combatant at which they're aimed. It is reckoned that 2 Harpoons will disable a frigate, 4 will knock out a missile cruiser, and 5 will destroy an aircraft carrier. A mix of over 20 of these weapons can be carried by a Collins boat at any one time.